Hello students, welcome back to video lecture series for the subject Mathematics 3 for all my mechanical engineering students. And in today's session, we discuss about Gaussian quadrature formula. Okay, so this is the last topic of the second chapter, numerical integration. In previous lecture, we discussed about trapezoidal rule, Simpson's 1/3 rule, Simpson's 3/8 rule. So in today's session, we discuss about Gaussian quadrature formula. This is also one of the method. So we can find approximate value of integration. So Gaussian quadrature formula. In your syllabus, we have only discussed about 1-point Gaussian quadrature formula, 2-point Gaussian quadrature formula, and 3-point Gaussian quadrature formula. Okay. So 1-point Gaussian quadrature formula, 2-point Gaussian quadrature formula, and here is a 3-point Gaussian quadrature formula. The formula is very important, and for that, for use Gaussian quadrature formula, the integration must be from -1 to 1. Suppose your integration is not from -1 to 1, so first you have to convert your limit of the integration from -1 to 1, and then you can apply this Gaussian quadrature formula. Either you apply 1 point, 2 point, or 3 point, but first you have to convert your limit of integration from -1 to 1. Okay, so integration from -1 to 1 f of x dx, that is equal to simple formula for 1-point Gaussian quadrature formula, 2 f of 0, 2 into f of 0. But 1-point Gaussian quadrature formula is not so much accurate, so that's why we use 2-point Gaussian quadrature formula. Okay, integration from -1 to 1 f of x dx, that is equal to f of -1 by root 3. Okay, f of -1 by root 3 plus f of 1 by root 3. Okay, f of -1 by root 3 plus f of 1 by root 3. And 3-point Gaussian quadrature formula, integration from -1 to 1 f of x dx, that is equal to 5 by 9 f of minus square root of 3 by 5, okay, plus 8 by 9 f of 0 plus again 5 by 9 f of square root of under root square root of 3 by 5. Okay, so this is a formula for 1 point, 2 point, and 3 point. 2 into f of 0 for 1-point Gaussian quadrature formula, f of -1 by root 3 plus f of 1 by root 3, that is 2-point Gaussian quadrature formula, and 5 by 9 f of minus root 3 by 5 plus 8 by 9 f of 0 plus 5 by 9 f of square root of 3 by 5. This is for 3-point Gaussian quadrature formula. Okay, so for examination, first you have to remember all these three formula. 2 into f of 0 for 1 point, f of -1 by f of minus square root of 1 by root 3 1 by 3 plus f of square root of 1 by 3, that is for 2-point Gaussian quadrature formula, and for 3-point Gaussian quadrature formula, that is 5 by 9 f of minus square root of 3 by 5 plus 8 by 9 f of 0 plus 5 by 9 f of square root of 3 by 5. Okay, so evaluate integration from -1 to 1 dx, 1 plus x square dx by 1 point, 2 point, and 3-point Gaussian formula. Okay, here you can see that the limit of integration is already from -1 to 1. Okay, integration, limit of integration is already from -1 to 1. So that's why you can apply direct formula. What is your f of x? F of x is 1 upon 1 plus x square. Okay, this is my f of x. Okay, so first 1-point Gaussian quadrature formula. So 2 into f of 0. So 2 into, put here 0. So 1 upon 1 plus 0. So you will get 2. Okay, easy. Now f of -1 by root 3 plus f of 1 by root 3. Okay, so instead of x, you have to take 1 -1 by root 3 and plus 1 by root 3. So first, because of here x square, so either you take positive value or negative value, both are same because of x square. So you will get 1 upon 1 plus 1 by 3. Okay, 1 -1 by root 3 whole square, so that is 1 by 3, and plus 1 upon 1 plus 1 by 3. So you will get 1.5. Okay, now use 3-point Gaussian quadrature formula. So this is quite interesting. for 3-point Gaussian quadrature formula, 5 by 9, this is my formula, 5 by 9 f of minus square root of 3 by 5 plus, okay, this is plus 8 by 9 f of 0 plus 5 by 9 f of square root of 3 by 5. So what is your f of x? Again I just write f of x is what? 1 upon 1 plus x square. So 5 by 9, 1 upon 1 plus, instead of x, first we put minus root 3 by 5, okay. Minus root 3 by 5 whole square, so that's why you will get 3 by 5 plus 8 by 9. See, this is my formula, okay. 5 by 9 f of minus square root of 3 by 5 plus 8 by 9 f of 0 plus 5 by 9 f of square root of 3 by 5. So 1 upon 1 plus 3 by 5 plus 8 by 9, 1 upon 1 plus 0, okay, because f of 0, that means instead of x you have to take 0. So 1 upon 1 plus 0 plus 5 by 9, again you will get 1 upon 1 plus 3 by 5. So the final answer is 1.5833, okay. So if you want to your answer more accurate, then you have to use 3-point Gaussian quadrature formula, okay. So this is the first example, 1.2.3-point Gaussian quadrature formula. Let's take one more example. This is quite interesting because here you can see that the limit of integration is not from minus 1 to 1, okay, that is 0 to 1. So first you have to convert your limit from minus 1 to 1, and for that you have to remember this important formula, okay. Sorry. So in example you have variable t, okay, so that's why left hand side you have to take t and right hand side you can take any variable. So just I assume I take x, okay. So b minus a by 2, this is the formula, t is equal to b minus a by 2 into x plus b plus a by 2, okay. So using this formula you can convert any limit of integration from minus 1 to 1, okay. So that's why you have to assume t equal to, b is upper limit, a is lower limit, so 1 minus 0 by 2 into x, okay, plus 1 plus 0 by 2, right, clear? So that's why t is equal to x by 2 plus 1 by 2. So finally you will get x plus 1 by 2. So t is nothing but now x plus 1 by 2. So dt is equal to dx by 2, okay. Dt is equal to dx by 2, okay. And using this formula, okay, x plus 1 by 2, you can check that when your t is equal to 0, okay, so x is minus 1, see, what is your t? T is x plus 1 by 2. So when t is equal to 0, this is 0 into 2, 0, x is minus 1, okay, and when t is equal to 1, x is also 1, see, okay, x is 1. So now your limit is from minus 1 to 1, clearly easy to understand. So here I just put all the value, t is equal to x plus 1 by 2, dt is equal to dx by 2. You can easily understand when t is equal to 0, x is minus 1, when t is equal to 1, x is 1, okay, easy to understand. Okay, now integration from 0 to 1 dt, 1 plus t, now convert your integration, see, okay, dt, instead of dt I just put dx by 2, so this is my dx, and by 2, 1 by 2 I just outside from the integration, and instead of t I have to take x plus 1 by 2. So here I just put value x plus 1 by 2, okay. So simple calculation and take LCM. So x plus, when you take LCM in denominator, so 2 plus x plus 1, okay. So finally you will get x plus 3, and 2 will be on numerator, so 2 will be cancelled. So finally you will get integration from minus 1 to 1 dx upon x plus 3. So now your f of x is what? 1 upon x plus 3. Now use 1.2 point and 3-point Gaussian quadrature formula, okay. So integration from 0 to 1 dt upon 1 plus t, that is equal to integration from minus 1 to 1 dx upon x plus 3. So 2 into f of 0, we know that for 1-point Gaussian quadrature formula we have to use 2 into f of 0. So 2 into 1 upon 0 plus 3. So finally you will get 0.6667. Okay. Now 2-point Gaussian quadrature formula. So that is dx upon x plus 3. Don't forget f of x is what? 1 upon x plus 2. Okay. So this is my 2-point Gaussian quadrature formula. Instead of x, first you have to take minus 1 by root 3. So minus 1 by root 3 plus 3. Okay. And plus 1 by root 3. Either you can take 1 by root 3 or square root of 1 by root 3. Both are same. Okay. So don't worry about that. Okay. So square root of 1 by root 3 plus 3 using your calculator. Okay. You will get this value 0.6923. Now use 3-point Gaussian formula. F of x is once again 1 upon x plus 3. This is my formula 5 by 9 f of minus root 3 by 5 plus 8 by 9 f of 0 plus 5 by 9 f of square root of 3 by 5. Okay. So you will get easily answer. Okay, and that will be approximately this answer 0.6923. Clear? Let's take one more example. Okay, so please all the students calculate this value. So ultimately you have to calculate this value 5 by 9. Okay, 1 upon minus square root of 3 by 5 plus 3. This is my first term plus 8 by 9 f of 0. F of 0 is what? 1 by 3. Okay, 1 by 3. I am using 3-point Gaussian quadrature formula plus 5 by 9 f of square root of 3 by 5. So once again 1 upon square root of 3 by 5 plus 3. So calculate this value, you will get almost 0.69 something or this value. Okay, so try to solve this example yourself using 3-point Gaussian quadrature formula. Okay, now next example, evaluate the integration from minus 2 to 6. 1 plus x square raised to 3 by 2 by Gaussian formula for n equal to 3. For n equal to 3 means you have to just use 3-point Gaussian quadrature formula. So first we have to convert this limit. We have to convert this limit from minus 1 to 1. Okay, so what is your variable? Variable is x. So that's why I just take left hand side x. Okay, suppose your variable in the statement t, then you have to take left hand side t. Okay, here my variable is x, so just I take x. The formula is b minus a by 2 into t. You can take any variable here. You can take y, z, whatever you want. Okay, so x is equal to b minus a by 2 into t plus b plus a by 2. So a is equal to minus 2. Just I calculate this. X is equal to b minus a. What is my b? B is upper limit, a is lower limit. Okay, so 6 minus 2 by 2 into t plus 6 minus 2 by 2. Okay, so x is equal to 6 plus 2, 8 by 2, 4t. Okay, and plus this is plus 2. Okay, so x is equal to 4t plus 2, and clearly you can understand that dx is equal to 4 dt. Okay, so put this two value in your equation. Okay, so now you can easily understand when x is equal to minus 2, t is equal to minus 1, and when x is equal to 6, t is equal to 1. So integration from minus 2 to put all these value here. So integration from minus 1 to 1, 1 plus 4t plus 2. Okay, now because your x and dx is x is 4t plus 2, dx is 4 dt. So 4t plus 2 whole square raised to 3 by 2 and 4 dt. 4 will be outside, and when you calculate 4t plus 2 whole square, so that is 16t square plus 16t plus 4 plus 1. So 5. Okay, so 16t square plus 16t plus 5 raised to 3 by 2. So 4 into 5 by 9 f of square root of minus root 3 by 5 plus 8 by 9 f of 0 plus 5 by 9 f of square root of 3 by 5. This is your formula for 3-point Gaussian quadrature formula, and this is your function. Okay, what is your function? F of x or f of t, that is 16t square plus 16t plus 5 raised to 3 by 2. Okay, so first you have to take minus root 3 by 5. So 16 into minus root 3 by 5 whole square. So that is 3 by 5 plus 16 instead of t minus root 3 by 5 plus 5. Okay, raised to 3 by 2 plus 8 by 9. Okay, f of 0. F of 0 is what? put f of 0. So 16 into 0 plus 16 into 0 plus 5. So 5 raised to 3 by 2 just plus 5 by 9 f of square root of 3 by 5. So 16 into 3 by 5 plus 16 into square root of 3 by 5 plus 5 raised to 3 by 2. So the final answer is 358.6928. Okay. So in today's session we discuss about Gauss-Quadrature formula for 1.2.3. Okay, and in previous session we discussed about trapezoidal rule, Simpson's 1/3 rule, and Simpson's 3/8 rule. So in numerical integration chapter is complete now. Up to this, thank you.